Hey gang, today on lesson 62 we're going to talk a lot about triangles. Does my face look like a triangle? Kind of does, huh? Pretty awesome. It's for Triangle Day. We're going to classify them by their angles and their sides. Should be a piece of cake. You guys got this. Have fun.
Why don't you go ahead and start your warm-up and pause the movie, start your warm-up, and come back and check your answers, and then we'll get into the lesson and begin. As you can see, I completed my warm-up, and I'll give you some hints. This one might have been a little hard for you. Separate it out. That's like 5 times 8, which is 40, and 5 times 0.6, which is 5 times 6 is 30, so 5 times 0.6, we move the decimal over, would be 3. So we get 40 plus 3 is 43. Now this one is a smaller number than 2.5 because it's got a negative exponent, so that exponent moves over twice and becomes 0.025. Now this one, I subtracted 2 from 30, so I know that 10 times something equals 30, and that something is 3. This one, there are 1,000 grams in a kilogram, so this is 2.5 kilograms. Or you can think of it this way. That decimal moves over 1, 2, 3 to 2.5. This is the same divided by the same, so you get 1. Doesn't even matter what those numbers are. Same thing divided by same thing equals 1. This one I did a third of 24 is 8. 8 times 2 is 16. All right, there you go. Now we're going to talk about classifying triangles, and we do it 2 ways, classifying by angles and classifying by sides. So this is the angle way. Here we have an acute triangle. What that means is we have all of these angles are less than 90 degrees. Okay, because you remember acute means less than 90. Right means you have a 90-degree angle in there. And obtuse means there's one angle in it that is over 90 degrees. Now you're going to explore a lot of this in geometry, but let's just look at some fun stuff about that. If you have an acute triangle, that means all the angles are acute. And here's my angles abbreviation again. All angles are acute. In a right triangle, you can only have one right. If you had 2 right triangles, you wouldn't be able to, or 2 right angles, you wouldn't be able to close it. It would not be a triangle. Same with obtuse. If you had another obtuse angle, you wouldn't be able to close it. It would not be a triangle. So you only have one obtuse angle in there. So you've got all of them, 1 and 1. Okay. So let's go into an example here. It says, there's a little blurb in the book about this. Every angle, and we'll use this as an example, every angle in a triangle has an opposite side. And the opposite side is always directly across. So the opposite side from W is the line YX. The opposite side from angle Y is WX. The opposite side from angle X is WY. Now there's a fun phenomenon with that, with triangles, and that means that the order of length of let me just figure out what this missing angle is, and then I'll explain it to you. Okay, so we have 2 angles of a triangle, so that means we can get the third one, because we know that 61 plus 60 plus that missing angle must equal 180. Remember, all of the angles of a triangle add up to 180. So if we put those together, we get 121 degrees plus that missing angle, or we could just say plus, instead of missing, let's make it look nice. Instead of that missing angle, we're going to say angle W, okay, equals 180. So let's see, 180 minus 121. Well, 180 minus 20 is 60, and it's going to be 59 degrees because we got that 1. So angle W equals 59 degrees, right? So now we know all of our angle measurements. We now know, okay, so this is the smallest angle, W is the smallest angle, X is the middle, and Y is the largest. Well, their opposite sides also go in that order. So if that means this line, YX, is the smallest, and WY is the second smallest, or the middle, and WX is the largest. So just as the angles go in order from least to greatest, the sides opposite it have the same relationship to each other. So the question is on this, name the sides of this triangle in order from shortest to longest. Well, the line opposite 59 degrees is the shortest. So what we say is YX is the shortest, okay? The next one would be opposite 60 degrees, or opposite X, and that would be WY or YW, either one is okay. And then the last one would be WX, in order from smallest to greatest. And you'll learn a lot about this in geometry. Okay, turning the page. And now they're going to, which sides of this triangle are the same length? Well, again, we need to figure out what that missing angle is to see the relationship between the sides of all these things. Okay, so I can make it look very nice. Angle, or 61 degrees plus 58 degrees plus angle Q equals 180 degrees. So that's nice and neat, showing the reader exactly what you're doing. Okay, so I'm adding them now. 119 degrees plus angle Q equals 180. So 119 plus, so we know that we take 180 minus 119, and that's going to give us our angle, angle Q, and that is going to be 61 degrees right in here. All right, so I was hoping that, because they said we'd have two sides that are the same, we need to have two angles that are the same. So if we have two angles that are the same, their opposite sides are also, so the opposite side to him and this side. These little tick marks mean that they are equal. I know we've talked about that in class. So which two sides are equal? That would be QR and, sorry, I'm going to talk to you about that in a second. QR and SR are the same. Now, if we're talking about measurements, you would do QR equals SR, and you would leave the tops off of that when we're dealing with measurement. Isn't that weird? When we name them this way. When we're talking about their length, we name it that way. Just something else that's going to come up in geometry. But this is what they have in the book. All right, look at this one. In this triangle, JKL, find the measure of J. Oh, we want to know what's in there, right? Well, what do we know? We know that JK is equal to KL. JK is equal to KL, which is equal to LJ. So if all of their sides are the same, all of their angles are the same. So if all of their angles are the same, we virtually have 180 divided by 3, right, in order for those to each be equal. And so 180 over 3 equals 60 degrees. So angle J, we'd say measure of angle J equals 60 degrees. In fact, all of their measurements equal 60 degrees. Now, the other way we can classify triangles is by the length of their sides. Okay, before we did angles, now we're doing sides. And so we're not even looking on the inside. We're just looking at the length of the sides. Okay, a scalene has no side, not one of them is equal to any of them. So we have 3 different lengths. Isosceles has 2 of them that are the same length and a third that's not. equilateral, or we call that a regular triangle. Remember, all of the sides are the same. We write it that way. And also with equilateral, because it's regular, also all the angles are the same. In these guys, a fun thing about isosceles is that if these two are the same, then these two are the same. Because remember we said if you have the same length, your angles are going to be the same, opposite those. Okay, example, the perimeter of an equilateral triangle is 2 feet, so it adds up to 2 feet. How many inches is each side? So how do you do that? You have to do 2 divided by 3. Well, let's think about this. If it's 2 feet divided by 3, could we say turn feet into inches? So if we have 2 feet, we have 24 inches because there are 12 inches in a foot. And now we can divide. So that was just, you first have to convert. So that means each side is 8 inches, okay? Because we couldn't divide 2 feet. Wrong units. If we break it down to smaller units, then we can do it. All right, draw an isosceles triangle. This is really hard because it's right up there. Okay, not so much. But it's good to label to show that it's isosceles. Whoops. Do those things. And then maybe give it some letters. And yes, mine is not perfect. If you use a straight edge, I will be very happy. All right, now if you notice on the practice, I didn't write, there are pictures in the book, and I did not write them. So you're going to have to open your book to page 428 and do A through H, okay? I just didn't have time to put the pictures in. I know you can open your book and look, so why would I do that to myself, right? So go ahead and do this, and then pause and turn it back on. If you need help, come back and check, okay? So I'm going to go ahead and do them, and you can come back to this if you need help. So go ahead and turn it off and begin. Okay, and letter A, it was a right triangle. Okay, because it had a right angle in there. B was obtuse triangle, because it has one obtuse angle in there. C is, by its angles, what we're going to call that is, I don't know if we talked about it. You can look back in your book. I'm looking to see if the book talked about it. But it's neither right nor obtuse, but all those angles are actually the same. And so it's actually equal angular. Or actually, we're going to call it, so this one is, it has no, this one had no, wasn't right, so it has 3 acute angles. We can't say that it's equal angular, which didn't really come up this section because we don't know for sure all those angles are the same. So we're going to just say they are all acute. We can tell that. That is neither obtuse nor right. Okay, now the next one is by its sides. So I see I have 3 different sides on letter D, so that is scalene triangle. Letter E, all the sides are the same, so we call it equilateral or regular, but make sure you know equilateral. And then F has 2 that are the same, so they are isosceles. So, trying to be good here. Sorry, you have to watch me erase. And letter G, if we know that 2 sides of an isosceles triangle, so it's always good to draw a picture when they're giving you, discussing a picture, it's good to have a visual. 2 sides of an isosceles triangle are 3 centimeters and 4 centimeters. Okay, and so we don't know this, but it's an isosceles triangle. These 2 are not the same measure, are they? So this is either going to be a 3 or a 4. Okay, it's got to be a 3 or a 4. Now when we add them up, it's not 10. So what is its perimeter? So let's say if this was a 4, we would get 8 plus 3. If it was that, we would get 8 plus 3 is 11 centimeters, okay? The other one was 4 plus 3 plus 3. Here's our other option. And when we do that, we get 10. Now, back in here, it says the perimeter is not 10. So that is not it. So the perimeter is 11 centimeters. So you kind of had to do trial and error on that one. Well, okay, letter H. Name the angles of this triangle. They gave us... I want to make sure we use the right notation on this. And name them in order from smallest to largest. Okay, so angle L is the smallest because its opposite side is the smallest. Angle N is second smallest or second largest, I guess you could say. And angle M is the biggest because it's opposite. So those are kind of fun. I hope you enjoyed that. I sure did. And we'll see you on